Hey everyone, let me get the official introduction. Hi, I'm Anthony. I'm the community manager of the Ceph Foundation. This is our 2025 Ceph Community Google Summer of Code Internship Showcase. I'm not sure how many years we've done this. I think this might be the second or third year of doing this. So we have a few presentations to go through today. These are going to be some of the interns who participated in the Google Summer of Code this year. So I will get it started and pass it over to our first presenter. Please take it over.
Yeah, thank you for that, Anthony. Yeah.
Sure thing.
Yeah. Hi, everyone. This is Adish here. And this summer, I worked on the More the Merrier for GSoC 25 for the Ceph. My mentor was Yuval Lifshitz. So, what does this project do? So, this project essentially focuses on improving RDW's bucket notification flow. Essentially, we made it more, we improved the bucket notification flow by making the queue mechanism more scalable and balanced. So before I go on about what the project entails, I'll give a small background about persistent bucket notifications. This is a feature that was first rolled out in Ceph Pacific, and persistent bucket notifications guarantee reliable delivery of bucket events such as object puts, delts, multisinks, etc. And these notifications are backed by radars or persistence. And so essentially, how would a simple workflow look like? So let's say a client wants to upload an object, he does that. The RGW first passes the notification into a radars object. After this is done, this client then proceeds to do the actual operation of creating an object. Meanwhile, in the background, we have another RGW which asynchronously delivers that event to an external topic, which can be a Kafka endpoint or a HTTP endpoint. This mechanism ensures that no event is lost, even if the delivery RGW crashes. So we see that persistent bucket notifications try to solve a pretty important problem of telling the user like what operations have happened in a bucket. However, in the existing design there is a bottleneck. So under the hood, each topic corresponds to one particular radars queue. I mentioned in the previous slide that we persist notifications in radars, and this is done with the help of this particular queue. But this, however, creates a problem. This creates contention. Every RGW tries to acquire a lock on that same object. So at any given point in time, only one RGW can actively try to dequeue notifications from that object. Practically, this means that all writes and dequeuing happen through a single OSD, which forms a bottleneck and wastes cluster-wide concurrency. So we have identified a bottleneck in the existing design. So how did we go about solving that? The fix was to the fix was to shard each topic. That is, rather than map one topic to just one radars queue, now we map one topic to multiple radars queues in the radars backend. So now, for example, creating a topic called fish topic produces 11 objects, ranging from fish topic.1, all the way to fish topic.10. And it is to be noted that the number of shards for a topic is configurable, and we have this new option called RGW bucket persistent notif num shards, which can be configured to map the topic to how many ever shards that a user would want. But the default value is set to 11. And each shard again is implemented as a two-phase commit queue and can live on different OSDs. So now we are spreading writes across multiple OSDs. Since we always, in the previous iteration, we only had one queue for a topic. So we could always guarantee ordering of notifications. However, we will not be able to do that in this case unless we make some active changes towards that. So for that, for enqueuing, the target shard is chosen by hashing the bucket key and the object key, and we take a modulo of this particular result across the number of available shards. This ensures that notifications for the same object go to the same shard. Thus, we preserve per object ordering while spreading the writes across different OSDs. The real win for this design comes during dequeuing. Since each shard acts as its own queue, different RGWs can now handle different shards simultaneously. I think the can be better explained with an example. So let's say we have 10 RGWs and 3 topics. In the old design, we only have 3 queues in the global list queue. However, this means that at any given point in time, only 3 RGWs can acquire locks for each of these queues. So we have 7 RGWs sitting idle. This leads to an underutilization of 7 RGWs in the cluster. In the new design, we have 3 topics. This means we have 33 shards by default, which implies that all RGWs now actively try to acquire locks for all of these shards and try to dequeue notifications. This essentially ensures that we have a smoother balancing of notification delivery work and higher RGW utilization. So, to support this new design, what changes were done? Topic management operations were extended. Creating a topic now creates all its shards rather than just one shard. This is again based on the config option that we discussed in the previous slides. Deleting a topic again deletes all associated shards before going on to delete the topic itself. Switching a topic from persistent to non-persistent or vice versa would trigger appropriate cleanup. You either create shards on demand or delete shards on demand. So, from the POV of an admin, operations remain simple. But internally, now Ceph maps one topic to multiple queue objects rather than just one queue. Another impacted area was monitoring. The topic dump stats command was also updated to aggregate metrics across all shards of a topic. For example, the total queue depth and the event count. This ensures monitoring tools see one single logical topic view, even though under the hood it is now implemented as shards. For benchmarking, I used a VStar cluster with a single monitor, 2 OSDs, and 1 RGW. Notifications were pushed to Kafka endpoints. I compared the baseline single shard setup against 11 shard setup for object sizes of 4 KB and 4 MB. The objective of the benchmarking was to I measure IO throughput and latency for put and del operations. So for small objects, these were the results that we got. We see that the throughput almost doubled. We have in the normal standard notification flow, an object put took about 20 milliseconds with about 3.1K IOPS per second. In the new sharded notification flow, we see that a put happened in about 10 milliseconds with about 6K IOPS. We see that sharding has recovered most of the performance lost due to the queuing overhead in the initial design, as we have essentially limited the write contention. For medium objects, it is important to note that the notification overhead is just a tiny fraction of the overall I/O. So, however, we still see some improvement. In the original flow, we see that object puts result in about 369 IOPS per second at about 170 milliseconds. For the new flow, we see a slight improvement in about 400 IOPS per second with a latency of about 154.7 milliseconds. So while the gain is modest for large objects, the design remains consistently better across workloads. The feature is now merged upstream via PR64018. I've also documented the design in a Ceph.io blog post, and during my time here in GSoC, I also contributed to other features for bucket notifications such as zone filtering and negative filtering. So to summarize, sharded queues essentially distribute more work across RGWs. This ensures that we have higher RGW utilization, especially during the DQ phase. It removes the write contention for writing notifications to, rather than writing notifications one single OSD, we now write it to multiple OSDs. And it also enables better scaling when only a few topics exist. In short, more queues essentially means more parallel work and a happier cluster. Hence, the more the merrier. A big thank you to Yuval and the Ceph community in general for support of this project. And thank you for listening, everyone. And I'll open the floor to questions. So, yeah. I am done. Yeah.
I have a question. Adash, what was the when all your paws go in? What would you say was one of the biggest struggles you faced while working on your project, and how did you manage that?
I mean, the one of the biggest problems that I initially faced in the project was getting around the code base because the self code base was pretty huge, right? And so like, but I had a lot of guidance from the mentors and from you all especially, and also the Slack channel helped a lot. And but once I got a hang of going to the code base and the design phase, because once we settled on a final design, the coding was writing code wasn't a big challenge or roadblocker per se, but the initial phase of getting the hang on the code base, knowing which flow exists where, I think that was the difficult part. But it was mitigated by regularly asking questions in the Slack channel or the weekly meetings and with you all as well. So during our weekly syncs.
Great. I'm happy you overcame that. Any other questions before we move on? Definitely want to give each presenter the opportunity.
Um, yeah, hi. Just one comment. Maybe people are wondering if there's any resharding here. So we intentionally do not do resharding. The queue size is kind of limited, and there's no real point in making the whole thing complex. So if you want different number of shards, it's only working for the new queues. And this was also the same approach with backward compatibility, which is also something people are super concerned about. And we took the approach that if you have existing topics with a single queue, then this is just considered to be shard number 0, and everything else works into place. And existing queues are just going to have one shard, and it just works. And new ones going to have as many shards as you configured, and they can live together even in a mixed cluster where you have old RGWs and new RGWs. So we really aim for simplicity here, and I mean, uh, by solving the problem forward and not trying to fix existing issues. If you already have bug notification working, then it would continue to work as it worked before. So that's just 2 comments. And most important, I think, lots of thanks to Adarsh for doing excellent work, and including all the, I mean, he didn't mention that, but I mean, most of the work when you contribute to Ceph is doing, like, testing and writing tests and making sure that Jenkins is working and tautology is passing and all that stuff. So getting something to completion is usually a big challenge, and even more than the coding. And Darsh was really great in doing this part as well. So thank you so much.
All right, thank you. If we don't have any other questions, we will move on to our next presenter. Last opportunity. All right, cool. Thank you, Adash. I greatly appreciate your time here, and thank you for working on this project over the summer and sharing it with us. And you also shared a link to your blog post that you shared as well. So if you have not had opportunity to read this blog post, please scan the QR code. Now, definitely make effort to share this on our social channels as well. All right, so we'll move on to our next project, which was Warm and Fuzzy. We have
Hi there.
hey, thank you for joining us. Do you need to share your screen as well?
Yeah, I'll share in just a second.
Okay, cool.
Are you able to see the PPT?
Yes.
Okay. So, hi everybody. My name is Yash, and my mentors were Yuval and Pritha, and I worked under the project Warm and Fuzzy. So, let's look into what exactly did I do in this summer period. So I actually added slides for explaining what exactly Ceph is. So I guess we all know what Ceph is. So I just so let's look into the next slide. So I worked on the Rados gateway component, which was basically the like it stands for Rados gateway, and it was an object storage interface built on top of Ceph. So its main purpose is to provide RESTful APIs compatible with Amazon S3 and the Open Stack Shift. So the gateway acts like a bridge between the Ceph's object store and the external client's application. So this was just a very brief of what exactly Rados gateway is. It basically acts as the bridge, and we work on using the Amazon S3 buckets. So the goal of the entire project was to fuzz all the API endpoints which are provided by the RGW so that we can find security vulnerabilities and potentially exploit it to find vulnerabilities and fix them. So Wrestler is an tool developed by the Microsoft Corporation. Its basic purpose is to uh, fuzz the entire API endpoints. These API endpoints are provided and are defined in a structured format using the Open API specification version 3. So this API specification, we need to provide it to Wrestler so that the Wrestler will be able to understand the various endpoints which are available for our particular RGW, what parameters we can send to that particular endpoint, what uh, other parameter, as I mentioned, parameters, it can identify it and fuzz it with some garbage value to check how the endpoint will react to certain combination of parameters. As of why this tool is needed is because there are very as of now very limited number of tests which we can write manually. So this wrestler will automatically create all the combinations for us and create all the parameters which can be sent to the RGW endpoint, and it will just keep on fuzzing for the duration that we specify. So this is the role of wrestler. So what problems did we face and how did we tackle them? So the first problem was that the wrestler did not immediately support authentication with the authentication for the RGW. So it just supported basic token based authentication where we just specify username and password. But for RGW, we need to add the signature based authentication. So the first task was to add this to the wrestler. So we added this and we were able to get the wrestler up and running. So which was the first part and the first hurdle that we resolved. So the yeah, so this was the challenge that I mentioned. And how we use the library which is provided by Python in order to sign all the requests. So once we were able to combine like make wrestler work with RGW, we were able to get on to the testing phase. So testing phase is basically where we were able to check whether all the endpoints are working or not. So basically two main endpoints were covered: the bucket creation and the object creation, deletion, all operations of that. And there were certain other 82 endpoints which were special operations type, like such as tagging, versioning, policies. We'll look into policies in a bit more detail. So these were the second types of operations that we can perform. The major two one were the buckets and the objects. So with the testing, in the testing phase of the wrestler, it just used to check whether all the requests can be made or not. So these uh, so we have up until now we have the wrestler running and we have in the testing phase. So in the testing phase, we were able to fuzz with basic endpoints like that I mentioned. So we weren't able to find issues in this specific endpoints. So what we did is we expanded our scope, and we also started catering into the endpoints, the secondary endpoints, like the one special endpoints, like the one I mentioned, the versioning and policies. So for that, we uh, we added this policy fuzzing suite. So it basically is a proxy server which stands between the RGW and the wrestler. So the wrestler will be responsible for creating the endpoints, to creating the request for those endpoints. Then our proxy server will essentially create different fuzzing. Will create the first policy. It will be a combination of any of all the valid, invalid, and everything that any malicious policies that we can enter, and it will be a combination of all that. These policies would be then attached to the request that was created by the wrestler. Our proxy will then forward this final request to the RGW, and it will keep on fuzzing up until the RGW crashes, or any new error is found, or the time for the fuzzing ends. So what we able to so what errors we were able to find? We found out that this specific type of error. So when we were sending the AMZ copy source as empty, so whenever we send this header as empty, the it wasn't handled by RGW, which resulted in the RGW crashing entirely. So this was a very critical bug that we were able to find using Restline, which it wouldn't have been able to possible to find this bug if it weren't for Restler, since it tries all the possible combination that can take place. And this was one of the critical bug that we found. The rest of the bugs that were found, which resulted in status 500, or basically internal server error, was very minor bugs, where the basically when the version id was too long, the RW couldn't handle it when the version id or the file name is too long. So these were some and there were many more status 500 501 that we were able to find, but those were very low priority bugs. This was one of the critical error, uh, critical vulnerability that we found. So this is how Wrestler was used to find out bugs and the crashes in the RGW. And this tool can be enhanced further to integrate. And as of now, we have only covered three endpoints. That I forgot to mention. So the bucket, the object creation, and policy. These three endpoints are only be covered as of now. For the rest of 84 endpoints, we can expand it further. This tool. So the scope is very huge, and this automation testing tool can be able to help us find bugs and vulnerabilities and exploit them in RGW, so that we can fix it before it is exploited by an attacker. So this is how the wrestler was integrated with RGW, what issues we found, and what can be done in the future. So yeah, that was my time. If anybody has any question, I'm happy to answer.
Thank you, Siash. I have a question. What piece of advice would you give to someone who wants to do the internship next year? What piece of advice would you give to another person who's going on this same adventure that you went on next year? Would go on this next year?
Oh, I would say to start early, because this was my second year contributing with Ceph. I started way back in October, even before the GSoC projects were announced, or any new news related to GSoC was there. So starting early is a very good thing, because you get familiar with the code base, the familiar with the community, how exactly the things work in Ceph or any other organization itself. So starting early and being consistent with the work, I think would be really good.
Nice. Thank you. And we do have another
Thank you.
question.
Yeah.
So, Yuval, are you able to? Okay, go for it.
Yeah, yeah. Sorry. Yeah, maybe some comment. So, Ash did great work there when it comes to kind of putting the basic infrastructure in place. So, as he said, there's still more work to do. But I think the most important next step is to wrap it and put that as a testing tautology to
Right.
do regression. Because, I mean, based on the existing code base, even if we don't expand the API testing, we found one critical security issue. Now, it doesn't look like a lot, but because it's a critical security issue, it is a lot. And the most important thing is to have that in place running as part of the nightlies and so on. So the next time somebody would mistakenly put in a critical security issue, it won't sit there for months or years, but would be caught immediately by using this tool. So that would really, so even if it happens once a year, it's still worthwhile the effort because of the severity of those kind of things. I mean, just to explain, um, an end user can crash the RGW at will. So this is critical, and this is exactly what the fuzzer is planned to be catching. Thanks.
And thank you, Yuval. You were the mentor for this project and the previous project. So thank you for your assistance as well in this campaign. So, do we have any other questions for? Do you have any other questions for us, Yuval, before we move on to the next one? All right. Thank you, Siva. Thank you, Sivash. We appreciate your time and thank you for working on this project.
Thank you, Yuval and Pritha. Thank you, everybody.
All right. So, move on to the next one. We have Ceph dashboard usability improvements. That person, are you here?
Yeah,
Aniket?
I'm here. Yeah.
Aniket. All right, cool. Thank you.
Hey, hey.
Awesome. Take your time.
Am I audible?
I can hear you. Yes, we can hear you.
Yeah. Okay. So I will just share my screen quickly.
Okay.
I hope you can see everything. Okay. Good evening, everyone. I am Aniket, and I had privilege of working with Ceph community this year as part of my GSoC 2025. My project was about rebuilding the notification system for Ceph dashboard. I did it under Afrin, who helped me a lot in this project. Okay, I will just give an introduction, brief introduction. So my project was about transforming how user experience system events or turning the small alerts into meaningful insights that actually help the administrator or the developer or anyone on the user on the dashboard to act faster. Okay, so before I explain my project, let me start with something foundational, the design system that shaped everything I built. So we were using Carbon design system for building the for rebuilding the notification system. So I will just give a brief about Carbon design system. Carbon Ceph Dashboard follows the Carbon design system, which is an IBM's open source design language. So Carbon provides like the beautifully structured UI consistent components like buttons or the toast models or tables. Like it have every component. So we are using Carbon in Ceph because it's a consistent visual language across all the features. Also, it has that VCAG accessibility compliance. That is for example, if you are using your dashboard in a dark mode, so it automatically changes the colors and color theme according to however what is ever the color theme of your devices. But however, what I was building was a new notification system for Carbon, and like the problem I faced was that Carbon did not have a notification component that matched our needs. So I had to build the notification system. I had to build everything from the scratch, and so instead of like using whatever was already existing, I built everything based on like by picking up small components from the Carbon design system, and then I like joined them together to build a overall new notification system that we are planning to like contribute it back to the Carbon community so that others can benefit it from it. Okay, so I will just move forward with like the problem with what why we were working on this project. So earlier, I will just share a screenshot, like the video from the last. Uh, okay, is this visible? So I told you what were the problems. So whenever anything failed, the number of notification flooded on the UI, and it just led to a poor user experience. So my goal was to like if something crashes, first of all, like you don't get crowded with all the notifications. So I first of all I changed the new toast. I added a new toast to the. So if you see here, this was how it looked before. The above one, the upper one was how it looked before, and then I added it. Then I changed it everything according to the Carbon, and then you used to like get the new design that was the below one, the new design that I created. And the most important thing in this was whenever something failed, I added like in the notification panel, I added a mute notification button. So if you see this, I have a cluster running right now for testing. So if like you mute the notification, so now if anything fails, or even if you create something, like you don't get flooded with number of toasts. So like you won't receive toasts if you mute the notification, and then you can just work on the CL, like check the CLI, and then you can just make sure what it was failing, and then you can come back and like unmute the notification to get ready with new. Okay, so this was one thing I did. I introduced the mute unmute system to reduce alert fatigue. Now then I added then I created this overall notification panel, uh, which had it is based on. Okay. So everything on this is based on a consistent you get notifications according to the status of the notification. So for error notification, you have a proper symbol for different kind of notification: the warning notification, the error notification, or the success notification. Now, the most important thing in this is the view all thing. So basically, if anything fails, you can just go on this view all, and then you get this notification page where you can open a particular notification, and then you can check like where this notification came from the application. Like if it is received, like if it is an error notification, it will tell you the why, from which application it received. So this was received from Ceph itself, so it's showing Ceph. But if it is a error notification or some other notification that helps you identifying the issue, so you can just get it here itself that it is received from Prometheus, and it will show the message also that okay, this is the issue. Uh, so you do, like the user don't have to switch, or the developer don't have to switch between the CLI and the dashboard itself. So this was the main thing that was actually what we had to do. Also, the you can just search the notification, like the error notification. For example, if you get an error notification, an error toast itself that get lost within like 5 seconds, or within some seconds. Then you can just search the notification here. For example, if I search the created pool, so you can just search the toast here, and then you can view back to the error or the logs that was lost. uh, okay, so the few challenges I faced in this was like, first of all, the main thing was that this component was not available in the carbon design system, so I had to work on it. Like, I had to be like research everything from the scratch on how we can build this. So I followed a React design. This was the React design that I followed to build the new notification panel. And as you can see, this is how it looks now. So this was all I did. It was a great experience working with my team, and also, so the end result of my project were like, you can view all alerts in one place. You can like now repeat like mute all the repetitive notifications, and you can like view context and log of each of the notification. And like now you can have you have that trust that you don't lose important alert from the. It was a great experience working with Ceph community. My mentor also guided me through the design trade-off, testing, and everything, code review. Afrin was very helpful. Thank you so much, Afrin. I will end on this. Yeah.
Thank you, Aniket.
If anyone have any questions, yeah.
Ask one question. Yeah. Where do you see your project going in the future?
Okay, so one thing is that like as I told, this thing has reduced the repetitive shifting between the CLI and the dashboard itself. So as a developer, I think it's a like more useful, like if we can add it, like if I add this in the carbon design system, if I give it to like revert back for contributing this to carbon design system, it like this will help a lot in like putting this into new projects itself.
All right, nice. Do we have any other questions for our speaker before we move on? Gonna take that as a no. All right. Thank you, Aniket. Thank you for your time and thank you for sharing your presentation with us. Greatly appreciate it.
Thank you.
Okay. And our last presenter, we have Parfit with tautology on Podman.
Yeah. Hello, everyone.
You're
You hear me?
here.
Okay. So I will share my screen and start.
All right. Take your time.
Okay. I think that you are currently viewing my screen.
Yes.
Okay. So nice. Let's start. So hello, everyone. My name is Parfait, and this summer I work on Ceph Stack. So as part of my GSoC, so let's present Ceph Stack. So alongside me, I have my mentor that really helped me to go through this internship, or I will say GSoC, and I really wanted to create them. So Ashwarya, Junior, Valerie, and Zach, all of them really helped me to overcome this and find solution, understand the existing code base, and guide my, I will say, my flow. So uh, let's start by the idea behind Ceph Stack, why we are trying to build Ceph Stack. So the problem we are solving is that Ceph is a very big project, and to run it, it needs a lot of components. So we have to deploy many things like monitor, cluster, monitor, OST, Hadows, and very different components. And all these components to work correctly, we need to deploy them on a cluster. So a cluster is a collection of machines. So we need many machines to run a Ceph cluster just to deploy Ceph. And sometimes we need to just to run tests against Ceph. So even for integration test, we have to deploy a Ceph cluster. And that is a problem. Sometimes a new developer can come on the project and don't have a necessary tool to run tests against Ceph, or sometimes an experienced developer want to test few things before pushing, and all of that still need a cluster like the CPI lab. So the goal behind Ceph Stack is to build a tool that allow us to easily deploy a Ceph cluster without needing many machine, many computer. So the goal is just to deploy, to simplify, or yeah, to simplify the Ceph cluster deploy, so we can run integration tests in local or any environment easily. So I start with the definition, and I say the tagline of Ceph Stack. So Ceph Stack is a simple tool to testing Ceph locally and using rootless Podman container. And the target of Ceph Stack, so Ceph Stack is built for all Ceph developers, testers, and especially new contributors, so new people that want to contribute on Ceph. And the major advantages that Ceph Stack offer is, first of one, first is that with Ceph Stack, a new developer no longer have to access API Lab before running its integration test. And even if I'm able to, before, if I have a cluster or I'm able to run integration test, it still need that I have dedicated storage device. So a lot of storage device to deploy OSD on. And with Ceph Stack, I don't need to have many storage device. Ceph Stack directly use loop devices, and we can easily configure our Kubernetes cluster with a simple configuration file. So Ceph Stack create a cluster, and just through a configuration file, we can configure the number of machine in the cluster and the number of OSD, the size of storage devices, and that stuff. So let's continue still with goal and motivation that lead us to Ceph Stack. And the first one is to lower the entry barrier for new Ceph contributor, so everyone can contribute easily to Ceph, and to be able to deploy Ceph locally. So just on my computer, I can deploy a full Ceph cluster to run test locally. And once I'm able to test my code against Ceph in local, I can make feedback easier and faster. So we can open PR quickly, and development will be easier. So I just said that. And the design of Ceph Stack. So Currently, Ceph Stack use Podman container, so we run different components of a Ceph cluster in Podman container, and each container run a different service. So currently supported service by Ceph Stack is PostgreSQL, so we need a database, and Pulpito, so we can view our test. So the Pulpito instance that is currently online, we can deploy a version, a containerized version of it in local to view how our tests are running. We have Paddle tautology, so to schedule a test, and we also use test node container as test node. So let's continue. So from there, the roadmap for Ceph Stack. Currently, we are able to run Ceph. We are able to run integration tests that need only one OST per test node. And my work on the project was to be able to make Ceph Stack run tests that need more than one OST per per test node. So that is what I did. And we have merged it and we are currently testing it. And the next step is that is also done is that made the OST size. So when we deploy a self cluster, we have storage device. So we want to be able to configure the size of OST of the storage devices through a configuration file, and that is also possible with Ceph Stack. And after that, the goal is to, instead of using loop devices to emulate a storage device, we want to be able to auto discover and use devices that are on the host machine. So Ceph Stack can automatically consume them and deploy OST on them. So I will quickly talk about the challenges that I faced during this project. And the first one was that since Ceph use a container to emulate test node and a machine is a cluster, we have faced a lot of issue with cell Linux role since it was not very easy to how to say it, to make some change like be able to mount created load devices on host machine to mount them on in machine on the cluster in the container, such thing. After that, the project also help us to find bug in the existing Ceph code base. So we have to fix them to be able to successfully test Ceph. We fix few bug to test Ceph the stack. So we fix few bug in Ceph repo. And the last challenge is that Ceph repo is not very aware of evolution of Ceph dev stack. So sometimes Ceph dev stack is working, and after a few change in the Ceph repo, it stop working because something goes broke. Or yeah, it basically that. So uh, I just drop the link of the project here. I guess maybe I will share a QR code or I will send it in the chat if anyone want to learn more on the project and see how to he can deploy a Ceph cluster locally and run testing against it. So thank you, and I'm there for your question.
Okay, thanks for the wonderful presentation. It's really helpful. So, just one question: why are we using rootless podman?
Can you repeat your question, please?
You have mentioned in the slides, right? You are using the rootless podman. So, why are we actually need a rootless podman? Why don't we use rootful?
why not a hopeful? It's more about uh, permission. So it's plus a security concern. So using hopeful container lead to more security vulnerability. I will say that is the main reason Ceph DevStack offer a opted for rootless container.
Okay. Yeah. Thanks. And one more question, like, so I just want to understand:
Hello,
is there
do you hear me?
any? Yeah, just want to understand: is there any scope in future that we can run this container based tautology as a tautology suite? Actually, like, is does it like if I have to onboard new hardware, okay,
Hello.
and hey, can somebody hear me? Hello.
Yes, we can hear you. Yes.
Okay.
I have a question. Perfect. What was your favorite part of working on this project? What did you enjoy the most while working on this project?
What I enjoy the most, I will say,
You can say finishing
it
it,
was a
getting to the end. But did you have like
yeah.
something that you learned or something that it happened while working on this project that you enjoyed the most?
I say what I enjoy the most is the self project as a whole. It's a very big project, and it was the first time I had to go through a so hard code base. So I think that was the most interesting thing. Uh, Trying to understand a lot of parts. It was challenging, but it was very interesting. So I say the self dev stack, the self repo as a project, as a very big project.
All right, that's good to hear. Thank you. All right, last round. Do we have any other questions for? Oh, we have one in the chat.
Yeah. I just see it, and yeah, I think that is totally possible, and that is already what we are trying to build for to do with self stack. So, if we are able to containerize the tautology part for local development, I think that we can also do it in remote. If that is your question.
Thanks for.
All right, I'm going to assume there are no more
Hello.
questions. Oh, what was that?
Okay.
Okay, I'm going to assume there are no more questions. Do we have any questions for any of our presenters or any of our mentors at this point? If not, I would like to say congratulations to all of our for all of our mentees for completing your projects this summer. Big congrats to that. And look forward to hearing more from you all as you continue learning about Ceph and using it in your future projects. Um, I look forward to also like having more of these discussions throughout next year as well. I I'm starting to work on the campaign for creating the Ceph Tech Talks again, doing like a monthly session where we are able to just hop on and just have someone do a presentation like this. I think that would be really awesome. So look out for more details around that. And I look forward to seeing you all around the community. Oh, seeing you at CephLaCon. If any of you are going to be at CephLaCon as well, look forward to meeting you there. But thank you all and enjoy the rest of your day. And I'll get this